If you don't form through intramembranous ossification, then you probably form through some other process, like endochondral ossification. Now take a wild guess. Intramembranous ossification, we formed from an existing connective tissue membrane. Endochondral ossification, what do you think we formed from? That was a giant hint, that part. That was the hint. Just kidding. Chondro, what's it make you think of? Cartilage. Endochondral ossification starts with a hyaline cartilage model. Really? So all your long bones form through this process, like your humerus, your femur, your ulna and radius, all of your long bones. And you start out when you're a little slime in your mama's belly, you start out with a hyaline cartilage model that looks just like a femur or a humerus or a tibia, except it's made out of hyaline cartilage. Okay, so I'm going to draw it for you because, you know, you got to have a drawing of your long bone. Doesn't that look like a long bone? Of course it does. Now, is it a long bone? No, it's made out of hyaline cartilage. Your bones better not be made out of hyaline cartilage. It's made out of hyaline cartilage. What does that mean that it is surrounded by? I can't even remember actually if I told you this yet. I know I did. What's the structure that surrounds all cartilage except for fibrocartilage? Did I tell you that? I don't think so. It's the perichondrium. Okay. It's made out of dense, irregular connective tissue, and there is perichondrium surrounding almost all types of cartilage. And it's just a protective sheath, and it surrounds this hyaline cartilage model. There is a structure surrounding bone. It's not called a perichondrium. If you had to take a wild guess, $1 million on this question, can you answer it? What's the name of the structure that surrounds bone tissue? It's made out of dense, irregular connective tissue. Go ahead, take a wild guess. Did you get it? It's the periosteum. That makes perfect sense. The perichondrium is dense, irregular connective tissue that surrounds cartilage. The periosteum, dense, irregular connective tissue that surrounds bone. So what was this again? Perichondrium, because it's surrounding a hyaline cartilage model. Okay. The first thing that happens, if we're going to make some stuff happen, we need to, first of all, have some mesenchymal cells. Guess where they're living? They're actually living in the perichondrium. So we have some mesenchymals, our little friendly stem cells that are going to differentiate into osteoblasts. Now, who triggers this? I don't know. Somebody triggers the message that, dude, it's time to make some osteoblasts in this perichondrium. What do osteoblasts do, you guys? They produce bone tissue. So what's going to happen as the osteoblasts do their thing? They're actually going to produce bone tissue, which is basically going to form this kind of bony collar surrounding the model. Now, a couple of things are going to happen. First of all, just like you would expect, we have lacuna in here with cells, and those are chondrocytes, right? So you can imagine that we just have our little chondrocytes inside here, and they're just hanging out doing their thing. All of a sudden, we get a bony collar. The bony collar is like, it's like a bony collar. Do you want to wear a bony collar? I don't, because it's going to, like, choke me, and I don't like that. And neither do the chondrocytes that are hanging out in there, because as the bony collar forms, it cuts off diffusion. Do you agree with that? Can you visualize that? There's no blood supply in this hyaline cartilage model. And so if there's no blood supply, we're relying on diffusion. But you know what? We just stuck a freaking wall up between the environment and the cells. What are they going to do in there? The bony collar is going to cut off diffusion. And I'll tell you right now, these guys on the inside, my chondrocytes living in their lacuna, they're going to have a little bit of an, excuse me, oh shit response. They're going to start to die. That kind of sucks. And you know what? Like all of us who die, they're going to start pooping concrete. Really? I mean, I guess we could come up with an analogy for why that's actually, like, why? Why would you poop concrete if you were about to die? Because your food supply and waste product delivery removal system was getting cut down, was getting blocked. You're trapped in there, and you're, like, you can't get any food. So you start freaking out and pooping concrete. Well, what's going to happen inside here? Okay, it's called calcified cartilage matrix, or you can call it concrete poop. Calcified cartilage matrix, yeah. And then they start sending out messages like, we're dying in here. It's all bad. Somebody's got to come to the rescue. And guess what? Somebody does. What? There is a structure called the Periosteal Bud. What? It's basically a blood vessel. Okay, and does this make sense? The cells in there are saying, we have no food supply. The body says, we don't want you to die. We'll send you in some food. We're going to send in blood. Well, of course, that's how we get food in your body. So we got to have a blood supply. So let's send in some blood vessels through this periosteal bud. To the rescue. But guess who else is going to hitch a ride? I love this. Osteoblasts. And guess who else? Osteoclasts are going to hitch a ride. And the periosteal bud literally busts through the calcified collar and enters the dying zone. It's all bad. But now we have osteoblasts and we have osteoclasts. The clasts start cleaning up the cartilage matrix. The blasts start building bone. What? That says building bone. True story. And now we have bone. We're replacing the cartilage model with bone. And we do it all the way until your bones are now bones. They are not little hyaline cartilage models. They're made out of, they're bone organs now. They're bone organs in all places except for one for a little while. What is that place? It's the Epiphyseal Plate. I knew it would come out. Epiphyseal. Have you guys heard of that? Plate. The Epiphyseal Plate is a place where we still have hyaline cartilage. And this process is essentially taking place in your epiphyseal plate, and it allows for growth of your long bone, for length growth of your long bone. That's the process of endochondral ossification. Now, let's take a look at how bone and cartilage can grow.